Hi everyone, welcome back to my channel. In today's video, we're going to cover two interesting topics. So part 1 of my topics is how to implement a stack using a linked list. Part 2, conversion of infix expressions to postfix and prefix with an example. So we'll start with a stack implementation, where I'll walk you through the code explaining each line. Then we'll have I will move onto the conversation process. So let's dive in. Let's take a look at the code for implementing a stack using a linked list. So line 1, public class stack as linked list. We start by defining a public class, named stack as linked list. This class will contain our stack operations like push, pop, and pick. Line 2. Stack node root. Here we define a root node of type stack node. This will serve as the top of our stack. The stack node from the line 3, the stack node class represents each node in our stack. It stores two things, the data and the next. The data, an integer that holds the value of the node. The next, a pointer to the next node in the stack. The constructor stack node and data initializes the node with a value. From line 10, the isEmpty method checks if our stack is empty. If the root is null, if it returns true, meaning the stack is empty. Otherwise, it returns false. Now let's move to the core operations of the stack. The line 20, this is the push method. The push method adds a new element to the top of the stack. First, we create a node with the provided data. First, we create a new node with the provided data. If root is null, meaning the stack is empty, we assign root to the new node. Otherwise, we set the new node next to point to the current root and then update root to the new node. Finally, we print a message that shows the value pushed to the stack. Let's see how pop works next. The pop method removes and returns the top element of the stack. If root is null, we print stack is empty and return. Otherwise, we store the value of root data in a variable called pop. Then we move root to point to the next node, effectively removing the top of node. We return the pop value. Next, let's check the pick method. The pick method returns the top element without removing it. If root is null, we print stack is empty and return integer.main value. Otherwise, we return root data, which is the top element. Finally, let's go to the driver code to see how this all works. From line 62, in the main method, we create an instance 65, line 65. In the main method, we create an instance of stack as linked list. We then push three values, 10, 20, and 30. Each time we push, a message is printed. Then we pop an element which removes from the stack we print the pop value. Finally, we pick at the element which is now 20. So let's see the output. So the output is 10 push to stack, 20 push to stack, 30 push to stack, 30 pop from the stack. Top element is 20. That's how you implement a stack using a linked list.